Today we talk about Nernest equation, which is an important equation in analytical chemistry. We'll cover these topics: derivation of Nernest equation forms an example, and at the end we'll talk about equilibrium constant. Nernest equation is an equation that used to calculate the cell potential E cell in non-standard condition for an electrochemical cell. The general formula for the Nernest equation is this. Here we have E cell, which is non-standard cell potential, E naught cell, standard cell potential. Both we calculate in volt. For standard cell potential, that means under standard conditions, 1 molarity for concentration, 1 atom for pressure, and 298 Kelvin for temperature. E naught cell can be calculated using this formula: E naught cathode minus E naught anode. R gas constant, T temperature in Kelvin, F Faraday's constant, and number of electrons transferred in redox reaction, and 4Q reaction quotient, which is the concentration of product over the concentration of reactant. Nernst equation comes from Gibbs free energy for cell potential. Here we have delta G and delta G naught in general and standard condition. By using theory of thermodynamics, we can combine delta G naught, and Q reaction quotient in one equation. And after that, we substitute in delta G and delta G naught, and at the end we divide the whole equation by negative F and F to find Nernst equation. Gas constant R can be found using ideal gas law at STP, standard temperature and pressure. So here we write R is equal to PV over NT, and we substitute in the values or in the variables by these values. So here we use for pressure Pascal unit, and after that we divide the value by 1000 to convert from liter to meter cube. So we get 8.314 Pascal meter cube. So Pascal meter cube is equal to joule. Nernst equation forms. Nernst equation forms depend on the temperature that we have. Before we talk about the two cases for temperature, let's simplify the Nernst equation by changing len to log using logarithm law. So we pick up len Q is equal to log Q over log E. This is from logarithm law. So from calculator we divide 1 divided by log E. We'll get 2.303, and after that we can get the equation number 1, which is the simplified Nernst equation. In the first case, at standard temperature, T is equal to 298 Kelvin or 25 degrees Celsius. Just here we substitute in T, in R and F to get this Nernst equation. And here we have joule per coulomb equal to volt. At case number 2, just we use the equation number 1 immediately, and can we substitute in the values. Keep in mind that in both cases we use the same value for R and F, only the difference will be in temperature. Let's move to the examples. In example 1, we want to find the cell potential for this given redox reaction using Nernst equation. So first we write the given and required. So the given here, the concentration for lead, for cadmium, and the standard temperature. And since we have here standard temperature, we use this Nernst equation form. First step, find the standard cell potential E naught cell. So we determine first the oxidation and reduction reaction from the given redox reaction. And for E naught, for both oxidation and reduction reaction, comes from standard reduction potential stable. So now E naught cell will be 0.277 volt. And N equal to 2. As we can see, 2 electrons in both reactions, in oxidation and reduction reaction. The second step is to find the reaction quotient Q, the concentration of product over the concentration of reactant. That means cadmium ion over lead ion. 0.02 over 0.2 give us 0.1. Since we have all the necessary values, now we can use Nernst equation to find E cell. So the E cell will be 0.3066 volt. In example 2, we have here copper silver electrochemical cell. We want to find the concentration for silver, and we have already the concentration for copper. So first we write the given. E cell, the concentration of copper, standard temperature, E naught for silver and E naught for copper. And we want to find the concentration of silver. So since the E naught or standard cell potential for the silver greater than standard cell potential for the copper, so silver will act as cathode and copper act as anode. So now we can write the half oxidation reaction and half reduction reaction for copper and for silver. For silver here we need to multiply by 2 to balance the number of electrons. So now we can find the balanced redox reaction by cancel 2 electrons from oxidation and reduction reaction. So E naught cell will be 0.46 volt and N is equal to 2. From the Nernest equation, we can now find Q, because Q, we have the concentration for both product and reactant. But here we want to find the concentration for silver, which is what located in the reactant, as we can see from this redox reaction. So just we do small rearrangement in Nernest equation by moving E naught cell to the left side, and we divide 0.0592 over 2. So this will be the nearest equation to find log Q. Now we complete the solution. We have this given data. So this is nearest equation. For log Q, we can know it by using the redox reaction, the concentration of product over the concentration of the reactant. So we have here for copper ion over silver ion, and we have here to the power 2 for the silver, because in the redox reaction we have 2 Ag plus, and we can change from division to subtraction using logarithm law. So now we complete the solution here. We substitute in the values, and we do the simple calculation here, and at the end we multiply -2 for both sides. So we get -1.14 log Ag plus. So Ag plus will be antilog, or 10 to the power -1.141. So the concentration of silver will be 0.0722 molarity. To check your answer, we can use Nernest equation at standard temperature, and we will see that the E cell will be 0.422 volt, the same that given in the question. In example 3, we want to find the equilibrium constant for this given redox reaction at 25 degrees Celsius. So we have this redox reaction, E naught cell is equal to 1.24 volt. Just we want to explain how we can get this value for E naught cell. So we determine the oxidation and reduction reaction, and after that we can find E naught cell, cathode minus anode, so will be the same 1.24 volt. At the equilibrium we need to know two important notes, delta G equal to 0, so E will be 0, and this is from Gibbs free energy. And second, note that Q is equal to K. So from Nernest equation we can write instead of E cell by 0 and Q by K. So now we rearrange the Nernest equation. So this is how to find log K from Nernest equation. And just we substitute in the values that we have. So the K will be 7.76 multiplied by 10 to the power 41. So this is the way how to find the equilibrium constant using Nernest equation. Thank you for your watching, and don't forget to subscribe and like and share the video.